Okay, grade fours, here we are. We are at page 41. We're going to go through all the questions, and in the description below in the video, you can click on the question that you want to jump to if you have trouble with any particular question. I'm going to start with number one. I'm not going to do every single question. I'm going to do one from each so that we have a good sample of all the questions. So number one, question one, write the decimal in each blank below the number line. They give us three number lines. One, I think 1A is fairly straightforward. I want us to look at B, which I've drawn on the board. It starts at 5.7, and these number lines all increase by 1/10. So the way to think of a number line when we're looking at it is pretend that the decimal's not there, and you're just counting numbers. So 47 or 57, 58, 59, 60. So that's all you're doing is just counting up one every time. And so then you can put your decimal in. So you have 5.7, 5.8, 5.9, 6.0, 6.1, and all the way up to the end of the number line. So this is a good question because number lines don't have to start at 0, or they don't have to start at like a whole number. They can start at a number or a number and a fraction of a number instead of just starting at 1 or a whole number. Okay, so there's three like this. Now question 2 asks you, how are the scales in question 1 different? By scales, they mean the three number lines. How are they different from each other? Well, they're different because the first one starts at 1, the second one starts at 5.7, and the third one starts at 63.4. So they're different in that they don't start all at a whole number, or they don't start at the same place. And B says, how are they the same? Or they're the same because they all increase by 1/10 each time. So that's how they're the same. Okay, let's look at question 3. Question number 3 is just telling us that we use the word and when we are writing out these numbers in words. So for 3.1, it's 3 and 1/10. So before, we would never use the word and when we're describing a number or writing a number. And now we get to use the word and the and stands for the decimal. Okay, so I didn't write these on the board. I think they're fairly straightforward. Question 4 wants you to write out the word or the decimal. So question 4A is 7.4. And so I wrote it out here. It'd be 7 and, that's the decimal, 4/10. And then question C, 4C, gives you 19.1 would be the answer. So it's 19 and 1/10, and you would write that as 19 point decimal, that's the and 1/10. Okay, let's move on to page 42. Question 5, I'm looking at C. But all of these questions, they want you to understand that once you count past 10/10, you've just counted a whole one thing. Okay, so that's what we're doing here. So if you look at the example for A, they show you how to do that. But let's look at C. I've drawn on my whiteboard, and we have these. All of these are 10. They all have 10 is the division. Okay, so they're not any other. These are all divided into 10. So we have these 4 columns, these 4 rectangles divided into 10, and I've shaded it the exact same way as it is in the picture. And so the first task is basically count how many tenths there are. So you're basically counting each individual piece of pie, or however we've divided this up. So if we count these red shades, or in your book, you would have counted 18/10. Each one of these is a tenth. And if you count all the shaded ones, you count 18. And so 18/10, if you have 18/10, that means you have more than 10, so you have one whole thing, and you have 8 left over, you have the 0.8. So that question is basically showing you that there's a common thing here. There's a relationship, okay, between how many tenths there are and then whole units, whole things. So we have a whole cake, a whole thing shaded in, and we have leftovers. So 18/10 equals 1.8. Okay, so that takes us to page 43, where we're ordering and comparing numbers. So let's look there now. I'm going to go and put that on the board here. Page 43, question 1 is asking us, and is showing us, we're back to base 10 models. So we have squares and little rectangles. and at the top it tells us what those squares and rectangles are worth. Whole squares are worth one whole thing, and the smaller rectangles are worth a tenth. And basically we're back to just counting squares and rectangles and putting in the numbers. So for question A, they've done the first one, it's 3.6. The next one will be 3 whole things and 4 tenths, so it'll be 3.4. And then they want us to figure out which one is greater. Well, 3.6 is greater than 3.4. If you ever get confused, take the decimal away, and is 36 greater than 34? And that's a kind of a way to check yourself if you get confused with the decimal sometimes. But I want us to move on to question 2, where they're asking us to draw a base 10 model. So I've done the first one, question A, for us, and I've drawn the 2 base 10 models for those 2 numbers. So the first number is 9.7, or 9 7 tenths, and the second number is 7.9, or 7 9 tenths. So I've drawn both of those out, 9.7 and 7.9, and it's just a matter of us figuring out which one is greater. And by drawing the base 10 models, we can easily see that, well, this one has more big squares, so automatically it's the bigger number. It has the bigger amount, the larger amount of whole squares. So by default, it is greater than this number. So that's why the base 10 models and pictures help us, is because we can visually see it if we ever get stuck on the question like that. Okay, let's move on to page 44. We're almost there. This is where it gets a little more intense. There's a lot of questions on the page, so we can get confusing. All right, let's check out question number 3. I'm going to write it out. Question 3 and letter B, it gives us the number. Well, first they want us to break it down and tell the value of each of these digits, and then which one's greater. So I just wrote this number out, which is 43.6, and then I wrote out the values of these. So don't get confused when they're asking you the value. They want you to know, because of where it is in the number, the place value, if you just take that number and multiply it by the place value, what do you get? Well, it's in the tens spot, so 10 times 4 is 40. That's the value of the digit 4. 3 is in the ones position, so it is worth 3. 3 times 1 is 3. And 6 is in the tenths position, so it is worth 6 tenths. Okay, it's not a whole thing, it's just it's a fraction. So that's what they want you to, how they want you to write that out. And then they're asking us to see if this is greater than the next one next to it, which is 36.4. So again, it should be fairly obvious which one is greater. But when you're looking at 2 numbers that look similar, take the decimal for a minute and then just look at it without the decimal. So 436, is it greater than 364? Well, obviously, it's a bigger number. So that's one way to look at it if the decimal gets you confused. Okay, so I'm going to move on. I'm pretty sure that's pretty straightforward. Let's go to question 4. Question 4 is giving us a pair of numbers and wanting us to figure out which one's greater. And because they're stacked over each other, this helps us figure that out. So by circling the number that's different in those, then we can determine which one's greater. So the way you do this is you circle the first number that's different. So you go through starting over at the thousands or whatever, over this way, and you work your way back until you find the digits that are different. Okay, that's how you do this with all of these, and that tells you which one is greater. So obviously we start with the 4s, they're the same, 8s are the same, 5s are the same. All right, 2 and 8 are not the same, so we circle those, and then which one is greater? Well, 8 is greater. So because 8 is greater, then this is the greater number. So that's what we'd write for our answer. But let's just for a second, I want to do something. I want us to erase these. I'm going to put a different number in. I'm going to make this 7 and this a 5. So now, these numbers are also different, but the number that comes first are these ones. So because of that, it doesn't matter what the decimal is. It doesn't even matter that this is greater. It doesn't make it a greater number in total, because the first set of place value numbers that we come into that are different are the ones. So because they are bigger, greater than the tenths, this is what we go by. So go through each of those, find the number, the first number that's greater. That's going to tell you what the greater number is in total. question 6, again, it's asking us to circle the greater number. So we'll take B, 352.1 and 325.9. Let's write it on the board real fast like. Alrighty, which one is greater? Well, if you just glance at the numbers real quickly, they look nearly identical, except for the decimal, because when you look at this, your eyes can easily kind of get confused and not see that. That's why they put them over one another and you circle each one. So if we just look at this real quickly, this is where you need to take your time, go through each question and double check your work. So yeah, 9 is a bigger number than 1. So at first glance, if you're rushing, not paying attention, you will circle this, thinking, well, it's got a 9 in it. But for a second, let's just take out the decimals and let's just talk about these numbers without the decimals. 3,521 and 3,259. Which one's greater? Well, 3,500 is definitely greater than 3,200, so this is the greater number. Put the decimal back in, doesn't change, it's still a greater number. So that taking the decimal trick out will definitely help you if you get kind of overwhelmed with the amount of numbers and the decimal, okay? So do that if it helps. Let's move on. All right, so I took question 8B and I've done what they've asked. I've written them above one another and I've lined up the decimals. And by doing so, we can see which one's the greater number. I did it the correct way, and I've done it the wrong way. I'll talk about this in a second. So by lining up the decimals, okay, it helps us to, it's going to help us when we go to add or subtract these, but it also helps us to keep everything in order, and we can easily see which one is a greater number. And I know by looking at these, you already know, but believe me, this can get confusing when we're doing equations and we don't have things lined up. So for example, this is the wrong way. I've just written the numbers out over each other, but they're not lined up according to their place value. If your decimals don't line up, just stop, start over. You have to line up your decimals, okay? Then you can easily see which one's greater. And again, this is going to come in a lot later when we go to do adding and subtracting and other things with decimals. Okay, let's go on to question 9. Circle the greatest number. All right, guys. Honestly, I'm sure you can handle that. Circle the greatest number. Again, little hint. Take the decimal out if it helps. Question 10. Arrange the numbers in descending order. Descending means from greatest to least. Okay? So I'm pretty sure you can handle that, but let's just do one. Let's do B, just for the sake of doing it. So 10,002.4, 1,300.4, 989, and 7/10. So I'm sure you guys can handle that, but I want to write one out just so you can see that especially descending order means from greatest to least, as opposed to ascending order, which means from least to greatest. So question 11B. We've got 3 rows of numbers, which I've written out for us, and they just want us to put in another number that shows ascending order. So again, we're starting at lower and we're going to higher. So in the first one, they give us the first 2, and so we just want to put in another number that shows we're going up. So 614.4, 641.1, pick a number that's greater than both of those. It can be anything, but let's stay with the 6s, why not? So we'll do 6 and 48.3, say. Okay, so we're showing ascending order. Each of these numbers gets larger. Now for this middle one, I'm going to take out the decimals, and I'll put them back in a minute, because I think this trick helps if you're struggling with decimals. Is now we want to put in a number in between, not at the end, but in between these two numbers. So if we take the decimal out, this now becomes 6,144. And this becomes 6,411. We want to put a number in between, so let's go 6,244. Okay, now let's just put our decimals back in the right spot, and now we have the correct answer. You could put anything in here as long as it's between these two numbers. And in this example, in the bottom one, they want us to start with the first number, so we just have to pick a number that's lower than this. So let's just stay with 6. And we will go 6,044. We'll put our decimal in where it's supposed to go. So now we have a number that's to least, and it shows ascending order. We have one in the middle, it's showing ascending order, and we have one at the end, it's showing ascending order. So ascending to is least to greatest, and they just want to make sure you know which numbers are greater than or less than other numbers. So I think you guys can handle that. Let's do the last question. It's a number line, which we love. Question 12a. Okay, it's asking us to find three numbers on a number line, which you can do because you have eyeballs. And then it wants you to put those numbers in ascending order and descending order. So remember, ascending order is least to greatest, and descending order is greatest to least. So that's what makes that answer correct or incorrect, whether or not you remember that ascending and what ascending and descending orders are. Now, I'm not going to leave you to do that. I think you can handle that. Question B, I want to explain why it would be difficult to make a number line to mark the numbers 43.9, 9,432.2, and 432.9. So it gives us three numbers. Why would that be hard to do on a number line? Well, the number line would have to be massive in order for us to get from 43 all the way to 9,432. It's going to have to be a massive number line, or it has to be a normal size number line, but the little divisions that mark the number line would have to be so tiny that it would be really hard to write. So number lines are good, but they're not good for a huge expanse of numbers like this where there's just too many in between those. So it would be difficult. It could be done, but I wouldn't want to do it. Okay, that takes us to the end of 45. Okay, that concludes today's video on those pages that were assigned for homework. I went through them fairly quickly because I want to try to make the video short as possible. So after doing this and going through them, hopefully this helps. If you have any trouble, go in and make sure you do the quiz that is associated with this lesson. It's not difficult. And then there'll be other assignments, and we're going to jump in soon to, actually next, into adding and subtracting decimals. So it's going to get a lot of fun. All right, so have a great day, guys. I love you all. Bye-bye.